Living systems are highly sensitive to acid and basic conditions. As you can see on the pH scale here, it runs from 0 to 14 with 7 in the middle. 7 is what's called neutral. 0 through 6, or really 6.999, are all acids, and 7.0001 through 14 are all bases. And pH is defined as the percent of hydrogen, or these hydronium, H plus ions in the solution. The more free hydrogen ions, the more acidic a solution is. As I said, water, pure distilled water, is in the middle of the pH scale with a pH of 7, and any fluids above a pH of 7 have fewer hydronium, or H plus ions, and more hydroxyl, or OH minus ions, and are considered bases. So the closer to 7, the less acidic or the less basic. The closer to 0, the more acidic. The closer to 14, the more basic. So it works a little differently from many other scales, with sort of 7 being in the middle there. So acids in general, again, are going to have those H plus, those hydronium ions. They're going to tend to be reactive. Acids can donate hydronium ions to other chemicals, and a prime example of this would be the acids in your stomach. You can see everything from the red to yellow on this scale are all acidic. So black coffee, soda pop, hydrochloric acid, and battery acid are all acids. Hydronium ions are going to make up bases. They're going to have more hydroxyl, OH minus, than hydronium, the H plus. They're going to tend to be bitter tasting. They're going to tend to be greasy. And these are going to be, examples include antacids, baking soda, milk with magnesium. Everything on the darker green to blue and purple on the scale are bases. So take a moment to answer this question, pause the video, and restart it once you've had time to answer. So I hope you've had a chance to answer the question. This was just a multiple choice, and hopefully you found that it was number 2. If you have any questions, feel free to send an email or ask a question through CELI if you're not sure why. And blood pH. pH is one of the factors that is important for homeostasis, that our bodies have to maintain within a small, very narrow range for us to be healthy. If our blood pH is normal, which is slightly basic, 7.35 to 7.45, then we're happy and healthy. If it becomes even slightly more acidic, closer to 7, we suffer from acidosis, which is dangerous to life-threatening. If it becomes slightly more basic, 7.45 to 7.8, we suffer from alkalosis, which is equally dangerous and potentially fatal. And outside of either of those ranges, even more acidic or even more basic, death can occur. So it's important that our bodies have mechanisms to absorb excess hydronium, excess of those H pluses, to keep our bodies from becoming too acidic. And we do have enzymes and other molecules that are able to absorb excess H plus. If our blood becomes too basic, there's an increase in the OH minus, the hydroxyl ions, then we can also release additional H pluses into the bloodstream to counteract that. And when everything is functioning properly in our bodies, we are capable of doing that and do maintain that narrow 0.1 range for our blood pH. But for example, with diabetics or people who suffer from hypoglycemia, they have difficulty doing this and can have some very serious health issues as a result.